Hey everybody, so we are moving on to lesson 3.6 today, writing algebraic expressions. And as I've been saying periodically, I show you your textbook because I strongly encourage you to be using your textbook as a resource in front of you and following along with what I'm saying. Because the video is awesome, but sometimes if I'm talking too fast or you need to pause the video, it may help you to look at the book as well because I'm following along with what we have in our book. So we are in lesson 3.61, writing algebraic expressions. And so the goal here is translate verbal descriptions into algebraic expressions with one or more variables, and then translate verbal descriptions into algebraic expressions with parentheses. So we're not going to start out with parentheses. What we're starting out right now are with one or more variables. So this lesson is all about the language of math, which you all are really, really strong in. You have done an awesome job so far about interpreting the language of math. So the first problem that we have here is Amy used 2/3 of a ribbon that is Y inches long to tie her hair. Write an algebraic expression for the length of ribbon she used. So algebraic expression means we're going to have a variable in there. There is going to be an unknown in the expression. So your first step is to always pay attention to what the question is asking. We know it's going to ask us to write an algebraic expression. That's the point of the whole unit. So that's kind of trash to treasure note-taking. I'm not going to underline that or highlight that or circle that because that's what we're going to be doing, writing algebraic expressions. I know that. But I'm going to be doing it for the length of ribbon that she used. So the algebraic expression should equal the length of ribbon that she used. That's what I'm trying to solve. So Amy used, all right, so now I know this is talking about what she used. And I say that because sometimes we get questions that it'll tell you what she used, and then it might tell you to find out what she started with or something like that. But in this case, they're keeping it real simple. This is what she used, and the question's asking me to write an expression for what she used. Well, she used a ribbon that was she used 2/3 of a ribbon that is Y inches long. So we know that she used 2/3, right? We know we can represent that mathematically. She used 2/3 of a ribbon that is Y inches long. So when we're doing math, usually, not always, but we do want to look for kind of keywords. Usually, you're really good about knowing that of usually means multiplication, right? And I would liken that to percents, right? Remember when we say 10% of 100, right? We know that, but 10% of 100 meant that we needed to do 0.1 or 1/10 times 100, which 10% of 100 would be 10. So most of the time of is a hint. We're going to use multiplication. And she used it of a ribbon that is Y inches long. So we know it's ribbon. That's specific to the problem. So I'm not really going to circle that, but it is important that it was Y inches long, Y inches in length. So what did she use? She used 2/3 of a ribbon that is Y inches long. How would we write that as an algebraic expression? She used, I like my colors, you know that. She used 2/3 of, which is like times, a ribbon that is Y inches long. Now you see why we get away from using the X symbol with multiplication. Now that we're in variables, that's confusing, right? Because you're like, is that a variable or does that mean multiplication? And then it's like, oh, well, we could write it like that, but I don't really see that once you get older in math. You don't really see the circle representing multiplication. Big boy, big girl algebra, we would write it as 2/3 y, and then we can't forget the inches. She used 2/3 y inches of ribbon. That would be the algebraic expression. She used 2/3 of, remember when the terms are right next to each other, it means multiplication, of a ribbon that is y, all right, 2/3 times y inches long. If I want to just test this out, just to be like, does that make sense? All right, well, let's say that she had a ribbon, we'll give it a value. She had a ribbon, because of course we don't know how long the ribbon was, and it was 18 inches long. So if she used 2/3 of a ribbon that is 18 inches long, and we're going to multiply, right? I'm going to cross simplify 1 and 6. 2 times 6 is 12. 1 times 1 is 1. That she would have used 12 inches of the ribbon. Does that make sense? If she used a ribbon, she used 2/3 of it, and it was y inches long, the length that she used, well, 12 is 2/3 of 18. We just plugged in that value, so it makes sense. And I would recommend, once you're learning this in the beginning and you come up with an algebraic expression, go ahead and what I did and just make up a value to substitute and see if your algebraic expression makes sense. All right, let's try another one. Okay, so they kind of go right to hard problems out of the gate. So again, I'm on page 166 if you want to follow along. A retailer doubles a coupon worth $T on a purchase of $15. Write an algebraic expression for the cost of the purchase. So remember, the first thing I told you is to really pay attention to what the question is asking. So we know we're writing algebraic expressions. That is what this is what the lesson's about. But we're writing it for the cost of the purchase. Okay, so that's what we're trying to represent, the cost of the purchase. So our algebraic expression should equal, I'm going to even take out the word for. The algebraic expression should equal the cost of the purchase. All right, so I got to go back up here. A retailer doubles a coupon worth $T on a purchase of $15. So like, what does that even mean? You're like, I don't buy the stuff, my parents do. So this is saying if you buy $15 worth of stuff, you get a coupon that is double $T. So our unknown is like, what does $T equal? But if you buy $15, but you have to buy $15 at least once. You buy $15 and then you'll get a coupon that doubles worth $T. So, important information. It doubles, and it doubles a coupon. And it doubles a coupon worth $T, right? We know that's our variable. So, a coupon, what does a coupon mean? Does that mean you get money off, or you have to pay more for something? So if you get a coupon, that means you get money off. That means you get money deducted. So doubles a coupon worth $T. So if a coupon is doubled, it's -2 T. So this represents the coupon. You're like, Mrs. Sayward, why? Well, it's doubled. Doubled means you do it twice. It's worth double of T. So that's why it's 2 times T. But because it's a coupon, that means you're going to get money off. It's a negative. It's going to come off of the purchase price. So it is a negative because it's going to come off of the $15 that you spend. So -2T, but you have to spend $15. Negative 2t plus 15. So it's a coupon that doubles t, so you have to take it off, and you have to spend $15 to start. So it can be represented this way, or it could be represented, if I spend $15, I am going to get a coupon that takes off double of t. You could write it either way. $15 minus the coupon that's doubled the value of t. Either of these expressions would work. The book actually recognizes this as the correct answer, but I wanted to show you this because in a lot of ways this makes more sense to me. As you spend the $15 and then you get to take off, because it's a coupon, you're taking it off of your 15 and it's doubled t. So like I said before, I tend to just make up a substitute value. So just to check if I did it right. So I'm just going to make this up and say t is equal to 3. So if I go over here and I substitute negative 2 times 3 plus 15, and then 15 minus 2 times 3, and I probably will just write that. Doesn't really matter. So negative 2 times 3 is negative 6, right? Negative 6 plus 15. Negative 6 plus 15 equals 9. So the cost of the purchase, if t is worth 3, is $9. Then I come over here and I'm going to do 15, and then I have negative 2 times 3. Negative 2 times 3, negative times a positive is a negative. So negative 2 times 3 is negative 6. 15 minus 6 equals $9. So both ways this was represented, it works when I substitute. So that makes sense. The cost of the purchase would be $9 if the value was t equaled 3. It would make sense if a coupon is doubled. Well, if 3 is doubled, it's 6, right? Which is why we have this negative 6 and this negative 6. It's being taken off the purchase price. 15 minus 6 is 9. Negative 6 plus 15 equals 9. So I proved my point. The expression to represent the cost of the purchase is negative 2t plus $15, or 15 minus 2t dollars. And let's be honest, I think my way, this expression makes more sense than the book's way, but I wanted to show you both because they're both mathematically correct. Okay, here we are with our next problem. 7 sticks of clay are shared equally among 28 students. Each stick of clay weighs c grams. Write an algebraic expression for how much clay each student receives. So we want to start out with thinking, what is the question asking us to solve? So it's asking us how much clay each student receives. So we are looking for an algebraic expression that is going to equal, and that's where, again, I'm going to take out that word for here, because essentially what we want is an algebraic expression that equals how much clay each student receives. So to be able to find that answer, we've got to look at what we have for information. So we have 7 sticks of clay that are shared equally among 28 students. So we've got 7 sticks. I don't need to say of clay. We know this whole problem is about clay, but we have 7 sticks of clay. They're shared equally. So shared equally is giving me a hint that we're going to be dealing with some form of division, because division is when we share things equally, we separate them into equal groups. So this problem is going to involve division, and it's shared equally among 28 students. So we've got 7 sticks of clay that are shared equally among 28 students. So each stick of clay weighs C grams. So that's important, right? Like each stick weighs, we know each stick weighs C grams. So how much clay does each student receive? So for me, I would look at this and say, all right, well, there's 7 sticks. I'm gonna just look at like how I would tackle it is kind of like how much clay does a kid get, right? So if there's 7 sticks, and we know that they're shared equally, so they're shared equally, meaning they're divided or they're split between 28 kids. Okay? But we know big boy, big girl, algebra, algebraic expressions. At this point, this is not in the correct form. So mathematically, we would write that like 7 divided by 28, right? 7 sticks, and it's divided amongst 28 kids. So each student gets 1/4 of a stick of clay, right? So that makes sense, right? If there's 7 sticks and there's 28 kids, each kid is going to get 1/4 or 1/4 of a stick of clay. But I'm still not in an algebraic expression yet because I still need that variable. And what is our variable? The variable is the weight. This is the C grams. So the C grams is our variable. So each student gets 1/4 times C. So 1/4 of a stick, and that's going to tell us what the weight is in grams. So 1/4 C, and I'm just going to label it with the word grams. So each kid gets 1/4 of whatever that stick of clay is equal to. It gets 1/4 of that weight. You could also write this as C over 4 grams. Because 1/4 times C is the same as C being divided by 4. And you're like, Mrs. Hayward, no way, I don't believe you. Well, now I'm going to substitute and just say, let's say that they had a total of, I'm just going to make this up and say 32 grams. So I'm making it up and saying C is equal to 32. Okay, well, 1/4, well, actually, I want to keep this so you have your final answer here. 1/4, can you see that? 1/4 times 32. Again, I'm substituting 32 for C. I've just made that up just to prove if my expression works. I'm going to cross simplify. 4 divided by 4 is 1. 32 divided by 4 is 8. This would mean that each kiddo would get 8 grams. So let's think about that. If the total, if each clay weighed 32 grams, which is what I just made up, and a kiddo gets 1/4 of it, is 1/4 32? 1/4 of 32, 8? Well, it is. Let's double check here. If I substituted 32 for C and divided it by 4, 32 divided by 4 is 8. So it works. They're equal to each other. 8 grams and 8 grams. So the algebraic expression for how much clay each student receives is either 1/4 C grams or C/4 grams. All right, one more, and then you're going to do some practice. Okay, last one before you try these on, a couple of these on your own. So let's try that again. A fruit punch makes 7 quarts when made with R quarts of, and it's orange juice, I just abbreviated OJ. So when made with R quarts of orange juice or OJ. This time it's being made with 30% less OJ. Write an expression for the number of quarts of fruit punch made this time. So what we're looking for is the number of quarts of fruit punch made this time around. So write an expression. So what we're trying to do is an expression that equals the number of quarts of fruit punch made this time around. So what do we need to know to be able to solve this? Well, typically a fruit punch makes 7 quarts when made with R quarts of OJ. But this time it's being made with 30% less OJ. So we know that our expression is going to be less than the 7 quarts, right? Because typically it's 7 quarts when it's made with R quarts of OJ. But this time around it's being made with 30% less OJ. We want to find out how many quarts are being made this time around. So our initial amount that we need to start with is 7. And then it's less than 7. So in this case, we're going to end up using subtraction here because we know we have less OJ in there. So that less tells me that I need to take that away from my original amount. Now it's 30% less OJ, and R is our variable that represents OJ. All right, so R is OJ. It's 30% less OJ. So 30% of the OJ. We have the less right here because I'm subtracting it. 30% of OJ, right? This is what this is saying, 30% less OJ. All right, what can I substitute right now to, I'm doing this work on the side because I'll add it into my final algebraic expression afterwards, but I kind of want to work this through. 30% of OJ. So right now, I can substitute OJ with R, okay? So I just rewrote this. 30% of OJ means 30% of R, because the expression told us that R represents the OJ. So now 30% of R. But I wouldn't write it that way. All right, 7 minus 30% of R. That's on the right track, but it's actually not written completely as an algebraic expression. So what's the next step we could do? Well, we could say, all right, well, I know of generally means multiplication. So 30% R. 30% of orange juice. We're making less of it, right? So we're taking away 30% of the orange juice. But we're still not fully there because we know we can write 30% as a number and get rid of that decimal symbol. So 30% is the same as saying 30 hundredths, right? 30 hundredths R. Now I've gotten rid of my word R. 30% times R. 30.30 R or 30 hundredths R. And then I even know I can say that 30 hundredths is the same as 3/10. So see how I've kind of whittled this down and whittled it down? I started with 30% of OJ. All right, well, that's 30% of R because that's our variable. We know we can write 30%, the same as saying 0.30. We know of is multiplication, 0.30 R, and then we can whittle it down even more to 0.3 R. So 7 minus 0.3 R. 7 minus 3/10 times R will tell us the number of quarts of fruit punch being used. And I think I should probably label this with So let's say that, I'm going to use 100 because it's easy. Let's say that usually R equals 100 quarts of OJ. All right, let's plug this in. Well, actually, that's probably not good because we start with 7. Let's reshoot that. Let's say that it is 2 quarts of OJ. I just wanted to stop that because we would have gotten in the negatives if I started with 100, right? So 2 quarts of OJ. So I'm going to try this out. 7 minus 30% of 2. So 30% of 2, well, that's 0.3 times 2, which is 6, because I have 3 times 2 is 6, but it's a tenth times a whole, so 0.6. So 0.6 is how much it's the 30% reduced. So 7 minus 0.6, 7 minus 0.6, I borrow from my 6, bring my dust, 10 minus 6 is 4, 6 minus 0 is 6. That would mean that this time around, there were 6.4 quarts of fruit punch. And that makes sense, right? Because I told you out of the gate that whatever we get is going to be less than 7 because we reduced it by the orange juice by 30%. So this does mathematically make sense that we would have less than 7, that we would have 6.4 quarts. So our final algebraic expression for the number of quarts of fruit punch would be 7 minus 3/10 R quarts. All right, I'm going to have you try some on your own. Bye.